Oh,
The screen is okay. Please start the presentation.
okay.
That's great. Thank you.
Thank you. So thank you. I will talk on some preliminary work that we are doing in Mozambique. That is currently on my PhD. This work started recently, and we really want to try to do some much more work on Mozambique coral reefs. So this is our first approach and how to see what kind of methodology we can use on Mozambique reefs, especially to use as a proxy for biodiversity. Passive acoustic monitoring has really the potential to be a great method for surveying marine habitats. And we really want to know if we can use ecoacoustic indices to monitor and compare marine biodiversity in Mozambique coral reefs. This is also quite important because most of these methods are quite easy to collect and to analyze, are not invasive, are low cost, and usually can be easily done by in day and night, or can even be in long term. There are great advantages for countries like Portugal and Mozambique that we don't have much financial support. So I'm presenting our preliminary works to see if really ecoacoustic indices can be a proxy for biodiversity in this case. And so I'm in Portugal. This work was done on Mozambique, mostly in Mozambique Island, that is in the north of Mozambique, with that is quite full of not as good as we should have in terms of coral reefs, with some degradation, some degraded coral reefs, but even so with a lot of diversity and with a soundscape that is rich on fish sounds, that is mostly our major interest. I will present you some sound that we recorded. How you can see, we can hear some invertebrates, but we can also hear a lot of sounds that are almost sure from fish. And simultaneously in this place we have also a lot of human pressure. That's also one of the reasons that we really want methods to study this area and to monitor this area in the long term. We have a lot of illegal fishing, fishing with mosquito nets, scuba diving fishing, and even fishing with explosive that can really also be monitored through passive acoustic monitoring. That is quite an advantage. So what we did was we selected 33 sites of really similar locations in this area around Mozambique Island, that is in sea. You can see it here, Mozambique Island, Ilha das Cobras in the bottom, and then also North Sete Paus. And we did so several locations. We selected several locations. We did the recordings throughout the spring of 2017 and 2018. Each location was recorded more or less 24 hours. And we, in the beginning of each recording, we did 15 minutes of fixed visual sensors to record how many species we have in each location. That's our golden standard in this case for biodiversity. In terms of the analysis of the acoustic recordings, we try to be most simple as possible. We use it what was also presented in the morning, the software from Tosil Lab, and we extracted some of the indices that they have. The first one is not usually used, but use it because it can be a proxy for some level, that is some FFT coefficients. We also use it acoustic complexity index and temporal entropy, but in the end we only use it and test it when an FFT window. that can also probably change the results. So in terms of results, the first thing that we checked to do this work is, do we have fish sounds in these waters? And we researched the list of fish that we have in these Mozambique reefs. And in this case, we only found the general list for all the coral reefs in this country, but can be quite a proxy of what we can find also in these specific coral reefs that we recorded. And we found that we have at least 27 known vocal fishes there. And we have almost 200 species that are potentially vocal. So we have a lot of sounds that are voluntarily produced by fish that can really change the recordings, and then it ultimately might have an influence that can be used as a proxy for biodiversity and abundance of fish. So in terms of visual censuses, we counted in between 8 and 23 species per site, with the exception of 2 sites that we can use almost like control, that were sites between areas with coral reefs that were almost with no fish present. In this case, we are counting all the fish, not only the vocal ones. And the results that we have, I think, are quite nice, moderately correlated with visual censuses, either the sum of the FFT coefficients, the ICA, and the temporal entropy. But we also try to do something that is try to sum all these indices that were standardized by the mean, so we can have a mixture of the things that each index represents in the recordings, and we see that the correlation, it gets a little better. Is quite for us quite a nice result, so we can probably use this approach to start analyzing more recordings on this location, because at least it is partially correlated with the species that exist in the location. As a discussion conclusion, our preliminary results really show a correlation between these common indices with visual censuses. We think that the combining several indices might be a better approach. Can be in this way, but can also be in other ways that other authors already presented in some papers. Having really a lot of algorithms that are freely available, easy to apply, is one of the best things of these methods, because we can also try to have the government or ING doing this approach in Mozambique, and also is a really low-cost method, or can be really a low-cost method. However, we still need to be really need to be aware that there is a lot of variations that can be not due to biodiversity on these indices. We should always complement these indices and these passive acoustic monitoring methods with other more traditional methodologies. And we should always not consider this as the holy grail. We should always consider this with caution. As suggested by other authors, we always need to record a high number of hours, so we can really have a value that can represent each habitat. In our case, we only did 24 hours, but other authors suggest more than 100. That can be a little more difficult to do, but not that difficult. There is still a lot of a lack of basic knowledge on the normal soundscape fluctuation. That is quite important, then we can extract information from these values that we can obtain from the indices. And lastly, sound abundance and signal to noise ratio clearly influence most acoustic indices and the recordings, and we need always to be aware of that, and probably do the methodology like selecting the right place to put the hydrophone, or knowing if there is a presence of fish choruses that can really increase a lot or decrease a lot these indices, so we can have a more standardized and a nice method that can be used for these type of things. So in conclusion, we really think that this is can be a really cost-effective tool that we can use in Mozambique coral reefs, but we still need a lot of research. We do a lot of research to try to have the best interpretation of these values, and also to try to standardize these indices to use it in other close by habitats. And that's it. Thank you. And any questions?
Okay, thank you for your presentation, and for your research made in wonderful places. So this is one of the lucky points of bioacoustics and ecoacoustics, to bring us in wonderful places.
This was my supervisor, so he was the lucky one.
Okay. So any questions? And please unraise your hands from the previous sessions. Marco Gamba, please raise your hand. Otherwise, I wait for other hands showing up.
Sorry, I forgot to unraise my hand. Sorry.
No problem. Absolutely. So other hands for questions? Marta, please go on with your question.
Hello to everybody.
Wow.
Hello, Manuel. I was just wondering, maybe it's me that I didn't pick up it, but I was wondering about the duration of the recording you used for this preliminary study, about the number of visual sensors you used for this preliminary study, and about the problem of the visual sensor being not possible to be run during the night. So all the fish that produce sounds during the night, actually, you cannot be detected by visual sensors. Thank you.
So in total, we have 33 locations, but in this case, we only analyzed until now, we used 3 loggers for do all these 23, so we only used until now 2 of the loggers, so 20 something locations. We use it for this preliminary work, 24 hours for each place, for each site. And yes, it's true. Visual sensors is not a great approach to have really the biodiversity that is in each location, especially because some species can be only active at night, or maybe some species can be there and it can be cryptic, can be alien or whatsoever. So yes, but it's quite nice to see, at least in this case, a nice correlation between these two methods. So we are hoping to continue this work and probably do more work with other scientists that can do the traditional ecological part. That's it.
I see another hands. Not anymore. No other questions. Alessia? No. So I'm wondering about your sampling scheme. You just said that you recorded 24 hours for each site, but continuously or with a sampling scheme?
Continuously.
So you record continuously. Okay, that's
yes,
good.
Yes.
That's interesting. That's a good approach.
Yeah, we think so.
Any other question? Marta again, or you are to raise the hand? Okay.
Thank you.
What type of recorder did you use for your work?
Okay, so we used custom-made recordings because it's much cheaper. We selected some piezoelectric plates and added that with the audio mod. in a container, and that was for this type of work was quite nice. And we are also now using these same recordings to characterize the fish sounds. So they appear they are working quite nice, even though they are quite cheap. Each piece is like €2, and the logger is, I think, 50 euros. So it was we tried to have the cheapest approach in this case, and it works nice.
Okay, I see some questions on the chat. One is the question is, were indices run on a specific frequency band or on a full bandwidth?
We used a full bandwidth in this case. In terms of the sum, we only did a simple sum for now. It worked quite nice, but we standardized the values of each index using subtracting the average and the dividing by standard deviation.
Okay, another question is related with the environmental noise. How you
in this
take
case
into consideration ship or vessel noise in the area?
Yeah. In this case, we were quite lucky because in almost all recordings, we don't have much ship noise or vessel noise. We only had that on 2 recorders that we excluded for now. But we are the initial approach that we are trying to do is to probably do excluding that data by using SPL, selecting a threshold and excluding the data that we have fish ship noise, for example, or possibly trying to use percentiles. We also try that for this data and exclude the probably the biggest percentile and the lowest one. And also only include the medial values. Let's see.
Yes, the use of percentiles is often a powerful tool to exclude events that occur randomly in a low frequency, in a low percentage of time.
Yeah,
that's good. Okay, I think we can just pass on